15 plus years of industry and research experience, our upcoming speaker has more than 10 published research papers under her belt. Armed with a PhD in electronics engineering from IIT Bombay, she has a specialization in cryptology. In her current role at Capgemini, she manages the GRC Cyber Security Department. It's now time to deep dive into an interesting conversation on how secure it is to use cryptography in the blockchain. What are the different kinds of cyber attacks we need to be prepared for? And what are the steps we need to impart to overcome these challenges? Everybody, we bring to you Dr. Shravani Shahapure coming to your screens right now.
Good morning, everyone. Thank you, Dr. Niladri and OOPS India Summit for inviting me to deliver the station. Before starting the session, I would like to give a brief introduction about myself. I'm Dr. Shravani Shahapure, working as a manager in Cyber Project Capgemini. And my interest is recently is in privacy, data privacy, and privacy preserving machine learning. And also I worked on various projects of cryptanalysis. So core domain, if you will see, is cryptography and cryptanalysis. So in today's session, I would like to bring the community's attention, specifically blockchain's community's attention, deliberately towards the very important and sensitive topic of blockchain, that is security of blockchain. So first of all, that's the reason the name of the webinar is our blockchain secure? Our core discussion in the webinar will be revolve around the cryptography and the security issues of the blockchain. So, of course, I would like to bring up not completely the structure of blockchain, how it works, and what exactly the proof of work and all. No, I'm not going to discuss that, but I would like to bring your attention to cryptography and what are the challenges or the issues that we are facing and how we should address them. So in recent decade, the information technology has contributed fundamentally to the development of the financial market, reforming the way in which the financial institute interact with each other. And the essence of the blockchain is that it is a public, shared, and carefully designed record that allows mutually unknown individuals and institution to share the data in reliable ledger and carry out all kinds of transactions. So how it is possible? I mean, why it is possible? So the main and important reason this groundbreaking technology is developed from cryptography and peer-to-peer network technologies. It is said that it is nearly immune to majority of today's digital threats. Beside financial institute, blockchain and best solutions have made it into other industries such as real estate, healthcare, the media, as well as a government body. So, as I said, today's discussion will revolve mostly around cryptography and security of blockchain. So, before moving on to the discussion, let's see the agenda. I would like to briefly talk about the blockchain, that is the overview of the blockchain, and then the important key element of technology, or we can say that the key ingredient of the blockchain technology on which the entire trust of the blockchain is based, that is cryptography, and the way it is used. In my opinion, while studying about cryptography and cryptanalysis, I always come across that it's like cryptography and cryptanalysis, they are like a cat and mouse game. So cryptographers try to develop a good, secure environment for people to interact, to work. And cryptanalysis, or the hackers, they're trying to break it and see how they can enter into the system. And sometimes a cryptographer wins, sometimes cryptanalysts win. So it's like a chasing game. So we will see what are the attacks, how the cryptanalysts, hackers, they're successful breaking the blockchain, and how they made the community's life difficult. And last topic I would like to discuss about, definitely I can't ignore, is the rapid development in the quantum computing. And so we will see that what are the different attacks due to quantum computing, and is there any possible measure, or is there any countermeasures available for this quantum computing attack. So of course, due to timing constraint, I would be excluding the mathematical part in this sessions, and I would try to make it as light as possible. So when we are saying blockchain, is basically referring to the digital information stored in a public database. So digital information in the form of blocks that is stored in the chain. So blockchain records a transaction across a global network of the computer over the web, over highly insecure channel. That's very important. And we are saying to be, it's a very secure, highly secure. So block stores the information about whom the participants entity are, and also store the primary information on the transaction, such as date, time, purchase amount of your last transaction in chronological order. So a block of your purchase from a vendor would record your name, and unique digital signature is used to refer to your username. So each block stores the unique code called hash that allows it to be different from every other block. So we'll see that in this technology, how hash function is important, and how asymmetric cryptography is important. So hash code also ensures that the block in the chain are in sync with each other. So any change in the block, any change in the text, or any change in the information, it will definitely disturb the blockchain. All the information transferred is in the encrypted form, and every occurrence is recorded. This means that this information cannot be altered. One more important thing that makes this technology unique and wanted is the decentralization of the network. So it does not require any centralized authority or a control to look after this blockchain. Of course, it is bringing some challenges, but people like to work in mostly undominated world, and they wanted to work without control. So this technology helped a lot of people in that way. What are the potential use cases of this blockchains are? The potential use cases are automotive, defense. I mean, I could able to name few because my slide was getting clutter. So, but now you put a finger point, and every place you will find the importance of this blockchain. And so healthcare, supply chain, identity management, IoT is also taking a lot of traction in the blockchain. So why the blockchain is rapidly getting adopted, because we are becoming digital, and in digital world we want to be secure. And another important characteristics of blockchain is worldwide adoption. So it has been adopted worldwide, and it has been backing by many investors, both from banking and non-banking sectors. Also, this we all know that this has come up with somebody who is unknown to us, and that person launched the Bitcoin. And so it makes so I'll open this to you, those who know as well and good who has done that, or those who doesn't know can find out. So this is the open source technology. It is flexible. So all this is making the blockchain attracted towards by the industry and by the community. So let's see how what are the different components of the blockchain, and how it looks like. The first blockchain was created in January 2009, and it's a blockchain is a chain of blocks. Each block contains header and a transactional list. So we'll see that there are some important components of this blockchain. as there are different roles in the blockchain to be played, you can see in the diagram that the blockchain components are ledger, smart contract, consensus network, membership, event, system management, wallet, system integration. So you can see the definitions on of all these components on the. So ledger is normally contains the worldwide state of blockchain transaction. Then consensus network, a set of data and processing peers that continually maintaining the replicated ledger. Membership is something like manages identity and transactional certificates and other aspects of the access right. So this, there is one more problem recently community has identified is the privacy. So different researchers are working on this aspect of the privacy, because it's not blockchain is not only public, but it's shared and it is private, and there are some controls. So the privacy is one of the issue that has been currently discussed by the research community. Another important component we can say is the wallet, that is securely manage security credentials. So that is our passwords, the key that we can say. So the main elements of the blockchains, as I have seen, is the decentralization, and that means there is no central authority. Consensus model refers to the agreement among entities, and consistent model help decentralized network makes unanimous decision. So main three features of consensus model are consistency, aliveness, and fault tolerance. Another important thing is transparency and privacy. So the most appealing aspect of the blockchain technology is the degree of privacy it offers. Again, yes, it offers a degree of privacy, but how much? Because if you'll see some cases in IoT blockchain, the privacy is the major issue, and some of the attack can lead to the mobile number of the user. So that's why I'm saying is privacy is the issue that has been discussed by the research community. Of course, one more thing is the open source, then identity management and anonymity. Let's see the how our blockchain looks like. So this is general structure, and if you'll see, there are genesis block, that is starting block, and then block 1, block 2, block n, and blocks has structure like it has a block header and list of the transactions. In each block you will find. So there are actually three diagrams I wanted to put your attention to. One is the general block diagram, and then what is there in the block headers, what are those fields and how many number of bytes has been used, and then the previous hash, how it has been transferred to the next block. So every block in the blockchain begins with the 80-byte block header. Block header begins with the 4-byte in-version field, which specifies the version of the block, right? So there are some bugs in the version of the block of the Bitcoin, but as a Bitcoin system evolved, the changes were proposed and the bugs were fixed, and there has been brought the new features where these N version has been bug in the N version has been corrected. So the version number of the block indicates which features are supported by the transaction presently. Then next is each block is identified the double SHA 256. So hash 256, that is what currently they are using in the block header. So this block hash has been used. I mean, we'll see in detail like how it has been used, and in the Merkle chain. Then first block is the genesis block. So we don't have input from the because if you'll see in the header diagram, it has a second block which is called as the hash previous block. So when we are starting any blockchain, there is no previous transaction has happened. So we don't have the previous block. So we have to set it to 0. Then it also differs, like, it uses the hash function. So it has the 256 byte string, which is random. And when we are saying is 256 bits of string, the probability of two distinct block hash are getting collide or the same is very negligible. So we can consider hash as a unique identifier. And now let's move on to the next field, that is the hash Markle root, which is of 32 bytes. And this stores the root of the hash of a Markle tree. So the transaction in this blockchain uses double hash and of each of them, and it is computed. So we will see the detail of this Markle tree in upcoming slides. And then the next one is, of course, the n time, n bits, and n nouns, which are the fields. Those are related to the proof of work concept, and it's mainly used in the data mining. So now we got a fairly idea about what are the different components of minor components of the block, that is the header and the transaction list. So we'll see now the cryptography in the blockchain. So cryptography is a major part, we can say, and without which the entire blockchain will fail. So it is kind of a key to the security of the blockchain ledger. And blockchain uses cryptography in various ways. So there are mainly two types of blockchain, the cryptography that has been used in the blockchain, that is hashing and public key cryptography. The primary application of the cryptography focused on ensuring the security of the participants and the transaction. It just say that they are safeguard against double spending. And also the lack of influence of the central authorities on the operation. See, although these are some of the features has been provided by the cryptography, but there are certain attacks on on a double spending and DOS, and the hacker are trying to steal the private keys. So as I stated, that blockchain mainly uses hash and asymmetric key cryptography. And in some cases, it also used symmetric key cryptography. So we'll not go into symmetric key cryptography. Mostly they use AES-256 as it's said to be a very strong algorithm, right? So basically, we use the hash, and a function of the hash gives the benefits like uniqueness, deterministic, quickness. Reverse engineering is not possible because it's a one-way function. And asymmetric key cryptography allows the benefits like transaction over the insecure channel and the verification of the message. And so let's see how this tool has been used, right? So how public key and cryptography has been used in blockchain. So important thing is the signature and transaction verification. So it's a simple, I'm not going to go into actual blockchain. I'll simply explain how it works. So Alice and Bob are our favorite actors in every cryptographic book. You will find them. And so Alice has one document, and he is a plain document. So he used the hash function. Depends on what hash function he wants to use, but normally hash 256 is a favorite one. And then it will create a hash. Then a hash has been encrypted by using the private key, the user private key, and it will club like hash and the plain text is club and send over the insecure channel. It will be received at the receiver side, and hash will be sent as it is, and the document will be decrypted by using public key. And then we will match whether these two hash matches. So as I've stated that, a hash function is a collision free, and it's very difficult to create the hash, a similar hash, if there is a change in the data. So that's the reason we are so confident that blockchain is safe and there will not be any alteration in the transaction. So if it is matches, of course we are accepting it, and we are moving to our the next task. So another important element you must have observed in case of the blockchain header is the Markle tree. So it was originally proposed by the famous cryptographer Markle to quickly check the integrity of the block, right? So it's a mathematical data structure composed of hashes of a different blocks of the data, and which serves as a the root is a summary of the transactions of all the blocks. So it is a very important part, as it is very efficient and secure for a large containts. So this Markle tree can also be called as a hash tree. And this, as I have stated, this idea was proposed by Professor Markle, and it was patented in 1927. So Markle tree stores all the transaction in the block by producing the digital fingerprint of the entire set of this transaction. And it allows user to verify whether the transaction can be included in the block or not. So that means, as we have seen that there is a hash has been produced in the sign and verification, and if hash will not match, definitely we should not include into the blockchain. So I have try to consider the four blocks of a data, and how the Markle tree will store it, hash, and how it will produce the hash, and how we will come up with the Markle root. So first, data data A, data B, data C, and data D, they will produce hash A, hash B, hash C, and hash D. And then again, these two hashes combined together, HAB, and it is like again hashed. And similarly, at the right hand side, CD is hashed. And so it's like a tree. So ultimately, Markle root will have the summary of all the hash. So this again, hash AB and hash CD will be hashed together, and it will produce hash AD. And this is nothing but your Markle root, and that will be stored in the header of the blockchain, where the list of the transactions has been listed out. So now we have seen there are two important elements, that is asymmetric key cryptography and the Markle hash function. That means there will be definitely attacks on it. I mean, see, when I was working in the cryptography field, I mean, I'm still working, but when I started working, and when I had an interaction with different researchers during my research, they said if we will use cryptography correctly, it is very difficult for a hacker to break it. And best example is the ransomware attack. I mean, once the entire data is encrypted, it is very difficult to decrypt it back, and that's why the ransomware is very popular, and now hackers are using that strategy to threaten the organization. But still, there are some loops while designing the system, and so there are different ways we can attack. So I would like to state here very promptly that people used to get mixed with the hackers and cryptanalysts. Although cryptanalysts are currently working on the practical cases, and there are communities in research, like most probably I've found it in Germany, that in risk assessment, they are trying to include the cryptanalyst. But yes, it's a practice yet. So hackers, so they are just trying to see how we can enter into the system, and how we can destroy the system, how we can hack the data, or how we can alter the data. So this is comprehensive blockchain security risk. That it's a wonderful paper I have read recently on a blockchain research applications. I thought this is kind of a platform where I can give the community about what are the different network attack, different blockchain security risk that has been involved. So you can see that there is a network attack. A network attack, that is a DOS, routing attack, Eclipse attack, then a broader gateway hijack, DNS attack, remote side channel attack. I'll not explain what these attacks. I mean, community is very, very smart. So I'm just naming them to get an idea and to give an idea where what kind of attacks are there on a network side. Also on the endpoint security, there are 51% vulnerability, Sybil attack, mining malware, cryptojacking attack. Of course, there are many, but has been proudly used. Then intentional misuse, this injection, criminal activities, double spending, selfish mining, then jacking attacks, self-holding attack. In case of data protection, sensitive data exposure, privacy leakage. In case of code vulnerability, there is a misconfiguration, broken authentication, double spending again, then insecurity, insecure deserialization, wallet security, smart contract. And major, what I feel is even though machines are working fine and they are trying to help us, there is a human negligence that is, causing a lot of problem in the security. So insufficient logging and monitoring, that is one of the things, and security misconfiguration. So these are the different attacks, you can say. And while I am delivering this session, there might be a different attack has been mounted by the hacker. And so this community is very active. So we have to be very vigilant, and we have to, keep on eye on our system continuously. And there where the security researchers and analyst role is. So again, I would like to bring down some major, vulnerabilities in the smart contract. Again, it's an attack on blockchain only. So vulnerability is a call to unknown. And of course, this is call to unknown cause and the attack on the Ethereum. Then field disclosure. It is a selfish miner published their private chain completely. It's on the Bitcoin. And then dangerous delegate call. The delegate call of code is identical to the standard message call. It's in wallet contract and Ethereum. Then exceptional disorder, gasless spend. So this actually, what you are seeing, smart contract vulnerabilities, the researchers are extensively studying the vulnerabilities of smart contract. And according to Professor Saurabh Sinha, whose paper I was referring and reading, who is working in University of South Korea, they said 8,833 out of 19,366 vulnerabilities has been found in the smart contract. And the Ethereum smart contract has a transaction ordering dependency, time span dependency, mishandled consumption. So these are the different vulnerabilities that we should look into. Of course, while talking about all this, I cannot stop myself talking about the quantum computing. And I would like to ask the question to the audience whether are we really are we into the quantum computing or quantum era, or we are already we have entered or we are entering. So there is a little confusion, and I'll leave it this to the audience. But yes, there is certainly a tremendous growth in this domain, and thanks to my favorite professor, Richard Feynman and Schrodinger, who has proposed the schemes or quantum long back, and people started working on it. And because of this quantum computing and quantum era, the most of these existing schemes, they can have a threat. As I have stated that cryptanalyst community is very, very strong, and they are always looking for an opportunity to break it. So Professor Shore, Peter Shore from MIT, has developed an algorithm which is called as the Shore's algorithm, which is used for prime number factorization. So, and with the different like a little modification into that version, we can solve even the discrete problem. And when we are talking about the prime number factorization, that means it is thread to our asymmetric key algorithm. As we have seen in the previous slides, that asymmetric key algorithm and hash function is an important element. If they collapse, then the entire system will collapse, and then blockchain will not exist. Another important algorithm, that is the Grover's algorithm, which attacks 51% and a hash collision. So as we are saying that SHA 256 is a collision free, or there are very less chances or negligible chances to find the same hash, but with the Grover's algorithm it is possible. And yes, that means people are working, and there are a lot of researchers I'm following. They are working on breaking the existing crypto system. Good news is, till today, I mean, I have not read it yet, but AES is a strong algorithm, 256. And of course, if we'll increase the key size, definitely it will be stronger. But I mean, it's not a guarantee. I mean, the RSA ruled over the world for 30 years. And it was one of the algorithm which drawn my attention and made me to think to enter into the field of cryptanalysis and pursue my doctorate. And I was so amazed with the simple concept of prime number factorization, how it is possible for to save such a contents for a longer time. But Shore has proved it wrong, and he had come up with the algorithm in 2015. And I remember I registered for my doctoral study in the same year, and I was going through some of the literature on RSA, and it was like a shock for me. Like, I have written one paper on 30 plus years of attack on RSA, and still it is there. But Shore shook entire world, and that's what the quantum computing is. So another important thing is that, are we ready for the quantum computing? And can we secure our system like before, and we can continue, or we have to discard everything? The good news is, yes, we can secure, and we are prepared. And NIST has recently announced post quantum cryptographic algorithm, which is published. I mean, final list have been published on NIST site on 5th July 2020. And there are algorithms which can save our existing system. So, of course, we have solutions, but still, anybody can come up with breaking the post-quantum cryptography algorithm also, and then we have to be ready again. So we cannot stop ourselves. We have to evolve each and every day, each and every second. We have to be vigilant. We have to come up with the solutions. And I would like to bring the attention of blockchain community to maybe they can use this post quantum cryptographic algorithm in the schemes, or modify their schemes, and check out on the different attacks that I have mentioned. And yeah, that's it from all my side, and thank you so much.